Hmm. Hello. Um, keep getting these weird stream disconnected. I am the world's greatest YouTubie. Um, so don't let the novice state of everything confuse you. I am using better hardware today. I bought a capture device, and now I look like I am a person rather than just a webcam person. Um, so hopefully the quality of this video is a bit better. No guarantees, because I am still very novice. So I did clean up my desk though, so you tuned into class just to hear that, but I was pretty proud of it. I'm a functioning adult. Does that sound convincing? Maybe not. So one of the cool features that I did learn how to do was I learned how to go from this view to suddenly this view. So where now, look, I'm looking at my screen and I got my hand out, and I just you can see my hand. Look, I'm in the corner. I can wave at you, but I'm looking at my screen. So that's pretty neat. I don't actually know if that's working. Oh, it is! Well, this is the greatest day of my life. No, it's not, but I do feel very accomplished. If the audio quality on this sucks, I bought a new microphone. There is no guarantees that this is anywhere near what it should be, but hey, I am trying. So this has been a learning process for me, and hopefully by the end of this, I'll be so good at YouTuberisms, that basically people will just look at me and be like, "We're the YouTube hero of our generation." No, that won't happen. Whatever. So last time, what we did was I just played around and I was building a structure for our pancake printer. And I put it into SolidWorks, cut out a few shapes, made it all pretty. I haven't touched it since last week, so maybe you haven't touched yours either. We do have about a month to go. I guess I would like to take a survey. Sorry, that's always my response to every survey. I want to do that. Yeah, that's not weird at all. I hope these live streams have been working out. It's been a lot of effort for me to try to make this happen. It's kind of cool. I am enjoying the learning process. But quite frankly, this is all work. So SolidWorks finally loaded up. No longer giving me the option of opening. Wait, no. I think I clicked out of it too soon. Just being too impatient. I feel like I don't have to yell. I'm wearing a microphone. Kind of cool. Go away. I don't see you. Oh, you mean get bigger? I don't want you to get bigger. I want you to get smaller. Why are you so unnecessarily irritating? Yes. Hi, I am teaching you SolidWorks, and I'm struggling with very unnecessary. I can't see it because the button I need to push is right here. I'm going to have to hide a few of these. And analysis preparation. Seriously? I just want this to go away, though. Hey. Auto show. So I click out of this. Alright, so I still go with user interfaces. That's awesome. I need this to disappear. It's not disappearing. So, awesome. Okay, so here's my structure that I built last time. Let me check. Okay. Man, I wish I could make that go away. It's like you can either make it stupid huge, or you can make it kind of huge. Either way, you don't like it. Ooh, I can go directly into the SolidWorks forum right here. Did not know that. I don't know this. Die. I only want you gone. I call you my only friend, but I have many friends. I'm gonna hide it over here. Not best practice. I cannot get that thing to go away. I want to pop this up so that I can actually see in case somebody leaves a comment. So, okay. I was doing so well at the beginning. Started out with a great video feed. Everything looks good. Anyways. Okay. What we're going to be talking about today is assemblies. Now, assemblies are kind of a weird... They're kind of a weird thing to deal with because if I were to just take this into an assembly, this looks fine. This is a great part. Perfect. But I haven't built this in such a way that I'm intending to connect things. The hardest part about any mechanical assembly, any one of them, is always going to be in how you get the parts to connect together. There is no nice way to just nice formula of, oh, well, just glue them. Like, no, that's not always best. And if you're looking at a system like this, where are you gluing it at? How are you making sure that it's staying in the same place? How are you going to glue it and then make sure that the wires connecting to it that are powering it are getting the power and they aren't being jumbled? So really, anytime you go to make an assembly, you have to start thinking, how are my pieces going to come together? What I'm going to do is to kind of simulate it. We're going to spend some time simulating this. And I'm going to spend some time doing something else. I'm going to create a new part. And my new part is going to be a hot plate that goes right in here. And the purpose of the hot plate is just simply to be a hot plate. Okay. So go to File, New. This is how you create new parts, new assemblies, or new drawings. Here we don't want to do an assembly yet. We're going to work towards it. But we're going to start by building a brand new part. Okay? I'll hit OK. And I've got a new part. You'll notice that my SolidWorks down here now has two windows in it. I can either go back to my structure or I could go to my brand new part. Okay. It's kind of nice to have both of them open. SolidWorks sometimes hates that because, quite frankly, it's murder on your CPU and your GPU. SolidWorks really hates GPU. But I'm going to go in here, and the first thing I'm going to do is go into Sketch, and I'm going to click Sketch. Sketch on the top plane, because that's how I roll. Make sure that my axes are orthogonal. Here, if it's not orthogonal, it's rotated like something like this. You can just click on the Y-axis, brings you right back here to where you can see your origin is pointing up and to the right, so we're in a good place. Clicking, if I double click here on the Y, whoa, I clicked out of the sketch. Hey, I'm going to click on top plane again. Now it's sketch 2 because sketch 1 disappeared. If I double click here on the Y, you'll notice that it flips this. What it actually does is it flips around takes your view and it looks at it from the back side. So like you're looking at the front side of your hand and the back side of your hand. Okay, I exited out of my sketch again. Double click out here, apparently it doesn't like it. Oh, he's done! I was not done. I want to make a plate. Now what I'm going to do for my hot plate is, my hot plate is probably going to have a heating element embedded in it. And it's probably going to be cast iron. A lot of hot plates they're very, very good conductors of heat. Basically a giant heat sink. Thick, sturdy, robust, impact resistant. We can coat it with Teflon. I'm not going to include the coatings on this. I don't know how to do that in SolidWorks, and quite frankly, just putting an arrow that says put a Teflon coating on this, way better. Does everything you need it to do. So I'm going to go back to my old file and say, okay, I'm going to be building a hot plate that is going to be going right in here, in this microwave-like box. I want to have some kind of a hot plate where there will be some connection for wires, there will be some place where I can bolt it in, maybe pin it in, something. But as I'm thinking about this, I gotta think, how are these parts going to go together? Because I'm going to have to make both of them such that they do go together. If they don't go together well, it's just like, hey, got this hot plate, throw it on there. You pick it up, it slides off. That's not quite good. How are we going to affix these two together? We have a lot of different connection options. You got bolts, you have glue. Glue and epoxy are acceptable. But if you're going to do something like that, usually it's good to create a profile on both pieces such that they fit nicely together, and then you epoxy it, because then it will always be in one place. The person who goes to assemble it will take the hot plate, put it out, cover the bottom of it with epoxy, and then stick it into some hole that has been specially designed only for the hot plate. That's good practice, because then there's only one method of assembling it. We are going to talk a little bit about design for manufacture, design for assembly later in another lecture, but just giving you a preview here. It's really important to think about how these are going to be built. I could build this fairly easily, but to try to attach anything to it would be harder the way it is built right now. First things first, I'm going to go to the top view. This is my old drawing, and now I've got this distance from here to here is basically my window between these four walls, or basically the window that I have to build a hot plate in. I can slide that hot plate in from the side, probably have to turn it at an angle, and then lower it down, and then connect it some. What I will probably do is, for my hot plate, just for simplicity's sake, I'm going to slide it in, and then I'm going to bolt it in at the four corners, and I would probably put some kind of special protruding bolt with maybe a rubber gasket or something. Have a rubber head on that bolt so that it doesn't, I don't know, probably coat that with Teflon too. In any case, I'm going to have to make bolt holes in this structure so that I can bolt it to it. Okay? Simply enough. So, first I need to know these dimensions so I can make a hot plate. What I'll do here is, I'm actually going to, before I build the hot plate, should have getting ahead of myself here. I'm going to go to the top view by clicking on Y, or I can go to View Orientation. Go ahead and click on that top view. Here I'm looking at the top view. I want to make a hot plate that goes in between these four lines. So that's awesome. going to go ahead and draw a circle. And this circle is going to... Okay, draw a circle. I clicked sketch and should have clicked sketch, clicked on here. I am now drawing directly on the bottom of where I want this hot plate to connect to. So, oh, come on. Just let me go back and see it. Okay, so here's the front corner, here's the front face of it. I'm going to create this circle. And what I'm going to do is I'm going to say, okay, what is a typical bolt dimension? Well, I like 1/4 inch bolts. So I'm going to go ahead and click dimension, click on this circle. What I can do with the dimension on the circle is I can say how big the circle is going to be. Right now it's 1 and about 3/16, which is a gigantic bolt. I don't need a bolt that huge to connect these. So I'm just going to type 0.25. Okay, it's going to shrink this size of this hole down significantly. And if I can zoom in on it, you can see it's still there. I don't know where it's located at. I just know I have a 1/4 inch circle that I'm going to turn into a hole. Okay, that's fun. Now I want to dimension from the center of this circle to this edge right here. I don't want to put my bolts directly on the edge, because then you might have a cast iron shatter. It's really not very strong. You might get some sliding in there. If you put it a little bit inset from the outside, it's better. So I'm going to put this in about, what I'll probably do here for my hot plate is I'll make my hot plate go all the way to the front and the back on this side, but then it won't go all the way outside here. So I could probably put this dimension from this face here to the circle. Now, if I click on the circle and I click on a line, it automatically goes to the center point of that circle because it realizes you can't dimension anything else on a circle. I can, maybe I could select a 1/4 point on this circle, which is top, bottom, left, right sides, but it automatically defaults to selecting the center of the circle. And I've got this line, and now it's calculating the perpendicular distance between them. That perpendicular distance. A point and a line only ever have a perpendicular distance. Because any other distance, like if my angle is going out this direction, suddenly that changes the dimension. If my angle is going out this direction, the dimension becomes much larger. A perpendicular distance is a constant value that you can share between a point and a line. So, click on this. I don't want it to be 2 inches from the outside. I want it to be 1 1/4 inch. Okay, so 1 1/4 inch from the outside. And then I'm going to dimension from this face here. Notice I can actually select the center point of the circle. If you just select the outside of the circle, it will also select the center of the circle. So it's like 2 different options to do the same thing. And you know what? I'm going to make this one come in also 1 1/4 inches. That's nice and square. So I got 1 1/4 inches from here, 1 1/4 inches from here. Good to go. This is my first bolt location. Okay, I'm going to unclick Smart Dimension. Now this circle here is fully defined. I'm going to want 4 of them, 1 in each corner. There's a couple different ways of doing this. You can do a linear sketch pattern and go ahead and specify this distance here, and this distance here. That's fine. I don't really want to do that, because if I change my dimensions here, then, well, you know what, I'll do it anyway. I probably won't make this dimension. I need to know some before I do a linear sketch pattern. I need to know my distance. So where are... I want to do a linear sketch. I want a dimension. I want to know how long it is from here. Oh, come on, let me select that. Oh, it's not letting me select that. Oh, that's unfortunate. Where is... Ah, there it is. So if you go into your Evaluate tab, you can click on Measure. Measure is basically like dimensioning, but it is specifically for, I want to know the distance between two lines. I want to know the distance from here to here. So here, if I click on these two lines, it'll tell me this, the 2 points that I click, this line is 14 inches long, which is great. This whole thing, I believe, is 16 inches long. But this distance here is going to be 12.17 inches, 12 inches in the X direction, and 2 inches in the Y direction. Now, one of the issues that we have there is one of the edges we're selecting is down here on this plane, while the other edge is up here on this plane. So there is actually a 2-inch drop between them. So if I just look at the distance number, it's not quite accurate. The X number is accurate because it's only in the X direction. You'll notice there's a 2-inch drop there. That distance is actually measuring across that angle. So if you're going to use the measure command, be careful because it won't give you a dimension just in that view. It'll give you a bunch of information. And you need to know which one of these to really look at. Here I only care about the X distance between here and here. I don't care about the Y distance. I don't care about the actual distance between those lines. I only want the X distance. So 12 inches is what matters to me. I'm going to have to make my hot plate 12 by 16 inches. Go back, look at the top of this device again, and I'm still in the sketch. I haven't left the sketch yet. Now I'm going to go ahead and create a linear sketch pattern. And on the x-axis, this is 12 inches. I have it in 1 1/4 inch. I want this to be 1 1/4 inch on the side, which means 12 inches minus 1 1/4 minus 1 1/4 is 12 inches minus 2.5 inches, which is 9.5 inches. So my spacing in the x-axis direction is going to be 9.5. Okay. I'd actually be putting it way out there. I don't know where. Oh, I haven't selected an object yet. Okay, in the y-axis, I don't want just one row. I want 2 rows. As soon as I do that, now I can enable putting something in the y-axis, and I want this to be this overall distance 16. This is 1 1/4 inch. I want this distance here between the hole and the outside to be 1 1/4 inch. So 16 minus 2.5 makes this 13.5 inch spacing. 13.5 inches. Okay. Notice it's still not showing anything up here. Nothing is changing. I've put in my numbers, did the calculations. I have 0 degree offset. I have 2 by 2, 2 rows, 2 columns. It's going to create 4 total. I haven't selected an entity to pattern. That's a problem. It doesn't know what I want to create a linear pattern out of. So I'm going to go in here, click Select Entities to Pattern, go in here and select this circle. Now as soon as I do that, you'll see it's created a rectangle. I want it to go this way. I don't want it to go this way. I want it to go that way. So what I'm going to do instead is I'm going to flip the direction of the x-axis. It'll move it this way. And now what I see is 1 1/4 inch from this direction, 1 1/4 inch this direction, 1 1/4, 1 1/4, all equal spacing. Kind of a weird optical illusion because there is no way this distance is equal to that distance. Oh, wait, that's right. We want this distance. We're in a good place. We're okay. And this distance up here is equal to that distance down here. Whole thing looks good. I'm going to hit yes. Now that's one way we could do it if we wanted to drill all the holes at the same time. We're going to hit exit sketch. it'll create those 4 circles. I'll go back into features, and instead of doing the extruded boss base or the revolve, which is also a cool feature, we're going to do just another extruded cut. You can do a hole wizard, but I don't like those. They're very challenging to work with for me. Never quite figured it out. Here it automatically selected the sketch plane because that's what I had picked. If I scroll around, it'll show you where these are cutting. It's only cutting 1/10 of an inch. You know what? Let's cut into this thing 1 inch. Let's have a nice, good, deep bolt set. We're never going to have this hot plate move. Okay, so I cut those 4 holes. Now I have mounting holes for my hot plate. Why is that important? Because if I think about how they're going to be connected, if I can make mounting holes also in the hot plate, I can align them, and that's going to very nicely allow me to connect these pieces together. So just thinking a little bit to the future. So I got my bolt holes here. Go into my brand new part. Here I am currently in a sketch. I'm going to draw a rectangle. This rectangle is going to go from the origin out like this. Hit escape so that I'm not doing a rectangle anymore. Click on Smart Dimension. This is going to allow me to size this rectangle to whatever size I want it to be. Click on this line. See, it's going to be 12 inches by 16 inches. 12. Here. Oh, I got so close. 16.36. Okay, my hot plate. It's very platey. We'll go ahead and exit sketch. I'm going to save my rectangle. We go over here, boss base extrude. And how thick do I want my hot plate to be? Well, what I want to do for my hot plate is I actually want it to be kind of a thicker on the outsides and then thin in the middle, so that like if you pour too much pancake batter on it or the pancake batter is too watery, it doesn't just start shooting everywhere. I don't want to get any pancake batter on any of my electrical components. So I'm actually going to extrude this out to be probably about 1 inch thick. It's a pretty hefty piece. And then what we will do is we will go back in and cut out pieces. Probably, since this is cast iron, it would probably be die cast. We'd have a cast of it. That means that it wouldn't require a ton of machining, which means we aren't losing material, thankfully. But it is still going to be a pretty heavy piece when we're done with it. We want this to be kind of like a bowl shape. But I'm going to start with I'm going to start by making this 1 inch thick. Okay, so here's my 1 inch thick, gigantic cast iron hot plate, which is unnecessarily huge. Awesome. Basically like a giant sheet. Now, I would expect on the very bottom of this, there would be some kind of a hot element. If I was really good at SolidWorks and I wanted to model that, I could. I'm not that good at SolidWorks, and I do not have the desire to actually model the hot plate elements. So I'm not going to draw on the heater element and how it plugs into anything. I'm only going to draw the hot plate. This is a freshman level class. A lot of you have never touched SolidWorks before, may not be very comfortable with it. So do be aware that I don't have gigantic expectations of you. Also, some of you won't be doing SolidWorks when you come up with your drawings. You'll be doing AutoCAD, where you will be doing hand drawings. So having the requirement that you got to be detailed, you've got to draw your heating elements, you got to draw your electrical connections, it becomes too much. So I'm just going to do this, keep it simple, stupid, KISS style, and we'll go from here. Now I do like making things pretty, so we'll keep it stupid while also being very pretty. I think it's a great way to flex your strength. So my first task is to take this plate and I'm going to drill those 4 connection holes, because that matters to me. So I'll do a second sketch. Sketch on this top plane here. I'll click on it, make sure that my orientation has got this flush. And then I will do the same thing that I did to create the other circle. I'm just going to draw a circle here. Go and smart dimension it. When I smart dimension it, it allows me to size that circle. So now this is going to be 0.25 inches. Tiny circle. And then I'm going to select how far it is from the edge. This was 1.25 inches. And I want this to select how far it is from this edge. I want that to be 1.25 inches. Huzzah! Got one hole. Now, the way that I did it last time was I clicked linear sketch pattern. It created a linear pattern of the circles, which is fine. It's great. I'm going to show you a different way to do it. Because we have similar circles that are going across, I would prefer actually to do it as an array of a feature. So here, a feature, what we're going to do first is we got the sketch. The sketch currently isn't doing anything. We got our other sketch that's inside of Boss Extrude. We got this sketch that's out here doing nothing. I'm going to, with this sketch selected, hit Extruded Cut. Here, I just wanted to go through everything. I don't care what the size of the plate is. I'm going to have a bolt hole that goes from the very top of the plate all the way down. Maybe not the best design practice. Maybe we should have started with the bolts on the bottom and screwed in so that the top plate doesn't have anything. But you know what? Yeah, I really like having bolt heads in my pancakes. So we're going to do it this way. I don't want to have a blind cut. I'm going to go ahead and pick through all both. That means everything that is inside of a cylinder in this plate will be cut. I'll hit OK. Now do keep in mind that if I do a cut extrude here, and then my next item on a tree, I could actually create a box that goes over the top of this hole. I can do that. That's perfectly fine. This cut, when I click through all, will only cut through everything that is above it on the tree. It won't cut anything that's beneath it on the tree. So if I had a box or if I drew a square on here, it's not going to cut into that later, as long as it's lower than the tree, if it's a feature I do afterward. SolidWorks is very step by step. So first step was get a plate. Second step was make a cut. Third step is mount something on top of that hole. It wouldn't cut through that hole if that's the case. Okay, so just a side note. I'm going to take this cut now, and I want there to be 4 of them. So what I will do here is in the Features tab, I'll click on Linear Pattern. Now I've got Cut Extrude already selected, so it's going to assume that the feature that I want to create a linear pattern is that, the Cut Extrude. Right now, I've got this one right here. Spacing is 0.1 inch. It's basically trying to move it this way, and oh boy! Although, wait, I don't have a direction selected. I'm going to go ahead and pick the x-axis. I can't do that. That's right. I'm going to go ahead and pick this line as edge 1 as the direction. And it's basically like picking the x-axis. Same thing, I believe, happens if you... Never mind. I think you can go back here and pick the x-axis. There's another way to select the x-axis. I'm not sure how to do that right now. But anyways, you can select this edge, and what it'll do is this is the distance along this edge that it will create that feature. And I want that to be, let's see, we had 9.5 inches for our x direction. cutting, you'll notice it automatically switches this way. You can switch it back if you need to, but it is cutting in this direction. So we've got one set. Now we've got a direction 2. I want it to go up. And here, instead of having one object, make it 2. I don't know why SolidWorks always defaults to 1. And I don't want it to be 0.1 inches. This is going to be our 13.5. Okay. You'll notice it doesn't show up there. So go ahead and flip this. Now it does show up. Flip it again, doesn't show up. Flip it again, now it does show up. If I flip it again, I see the holes down here. I'm not cutting into anything right there, so make sure to flip it so that it actually cuts to the right place. So yeah, now I've got these 4 holes are cut through a gigantic piece of cast iron metal. Awesome. What do we do with this? Well, first thing that I'm going to do is I'm going to cut a hole in the center here where I want it to be kind of like a trough for placing pancake batter. That way pancake batter won't spill everywhere when it goes on the plate. So first thing I'm going to do is I'm going to create a sketch. Sketch on this face right here. Orient my axes so that I'm looking right at it. And then I'm going to go ahead and I'm going to draw a circle. That is not a circle. It's been a long week already. So there's my beautiful four-edged circle. 90-degree angles. Escape. I'm not doing rectangle anymore. And I'm going to go ahead and dimension this thing. I'm going to dimension it off the edges. And I want this to be, let's see, we got 1.25 inches from the edge. I'm going to make this 1.75 inches from the edge. So it'll be about half an inch from the edge of that hole it's going to come in. That'll allow me to have at least a bolt head on this. Go ahead and dimension this too. Want this to be 1.75 inches. Awesome. Let escape. Now, I could put the other 2 dimensions on, but remember, I keep telling you that having relations are nice. I want this to always be in the center of this hot plate. So what I'm going to do is I'm going to select the midpoint here, hover over this, select the midpoint here. Close with it, where it was. Oh, I don't want to select the edge. I selected the edge. There. Apparently you have to have the edge selected in order to pick the midpoint. I'm going to make these horizontal. Okay? Hit yes. Now this will always be horizontal here. The midpoint of this line will always be horizontal. It'll always have 1.75 inches here on this edge. So if this plate shrinks in this direction, it'll still have that 1.75 inch gap. It'll just adjust accordingly. And I want to do it on this side too. So to do that, I go into add relation, pick the center point of this line. Oop, I've already got the other point selected, so I need to delete them out. Q, point, don't want the line. Okay, then we pick the point here. Make me pick the edge before I pick the point, which is annoying nuance. SolidWorks. And then I'm going to go ahead and make these vertical. So these 2 midpoints are going to be vertical. These 2 midpoints are going to be horizontal. I want 1.75 inches here. I want 1.75 inches here. That'll give me a 1.75 inch boundary all the way around. Okay. Using relations, if you understand geometry, really, really helpful. So here now I've got this rectangle. I'm going to go ahead and cut it in to this piece. So I'll exit sketch. I don't want this hole to go all the way through. I only want this to go part of the way through. So if you remember, we go to Features, Extruded Cut. I've already got the sketch selected. It knows that I want to cut into the material. If I pick 1 inch, I'm going to cut all the way through. I don't want this to go 1 inch. I want it to go 5/8 of an inch. So I'm going to do 0.625. Okay. quite cut all the way through, but it'll make it really thin and it'll give me kind of a nice trough there. So now I have a plate, and this plate has a hole, kind of a trough where I can pour my pancake syrup. I'm going to assume that down here there's some heating elements or something that's warming it up. Maybe the heating elements is actually in the base. I don't know. But I'm going to say this is good enough for my hot plate. Okay, so I will go ahead and file, save. When I save this part for the first time, first of all, I've got to navigate to my pancake printer folder. I'm going to want to make sure that I save it in the same folder as I save my structure. If I don't do that, it's going to cause me some problems. Now, do remember what I told you before is put all of your parts in one folder and have nothing but those parts and assemblies and drawings in that folder. If you ever need to make edits to this or create a new version of it, you copy the entire folder and paste it and begin working again. If you don't do that, you lose all of your assemblies and your drawings, and it's a really big pain to rebuild those. More than likely, you will end up having to do that at some point, because no matter how many times I tell you, you can't learn unless you do it yourself. What do you mean, put all your folders, copy the paste parts? Yeah, no, you will learn by mistake. Unless you can be really good about learning it the first time I tell you, the second time I tell you, 15th time I tell you, you will learn by making that mistake. So, okay, I'm going to go ahead and name this hot plate. It is a SolidWorks part, and this is looking good. So I know the spacing here is equal to the spacing here for these holes. I know this plate is flat on bottom, ready to be mounted directly to that. So I'm going to go ahead and go File, New, and create an assembly. Now I have the two drawing files open right now. I have the structure and I have the hot plate. When I go in to create an assembly, it's going to know that I already have those two parts open. What you do in an assembly is you take parts that are individual pieces, you hook them together. It does allow you to move pieces if they can be moved. It also allows you to connect pieces together. So we're going to talk a little bit about that. Now I've got my open documents right here. I got hot plate and I got structure. The first thing that you put down in an assembly, SolidWorks fixes it, locks it in place, assumes you cannot move it, which is kind of what I want the structure to be. I would suggest picking the structure first. And here I got my structure. Structure looks hot. Although it doesn't look as hot as the hot plate. Boy, I really wasted a joke on that one. But this is it. This assembly has not saved any of the geometry of this part. The way that SolidWorks has to work is it continuously regenerates a model based on existing parts. So if I go back and I edit this piece right here, it's going to know I edited it, and it's going to update the assembly. It'll ask me, and then it'll update it. SolidWorks does not save the geometries in the assembly. It does not. Okay? This is why you have to put parts all together in a folder, because if you lose one of those parts, it gets lost from every assembly it's in, every drawing that references that assembly. Assembly, it just causes a cascade of problems. So save all of your parts in one nice, neat folder. Okay, so I got this piece in here in my assembly, and there really isn't anything I can do. Assembly, when you're building assembly, the purpose isn't to edit the parts. It's not to make cuts, changes, anything. Remember, I said it doesn't save the actual physical geometry of this piece. So it's not intended, an assembly is not intended for me to actually go in and edit it. It is intended for me to put things together, assemble them. That's why it's an assembly. So the next thing I do, you'll notice on this tree over here, I have structures, structure 1 that is located here. I have all of the pieces that are associated with that have been imported. Okay, this entire tree here is the exact same as the tree I have here. And I can pop it out and look at it at any time. Oh, I did this with 4 cuts and 1 extrusion and 1 fillet. Okay, so that is one of the nice things about an assembly is you can look at that, you can reference it, you can click on it. It actually does allow you to edit it. It's never good practice to edit parts in an assembly because, wow. Oh, excuse me, getting tired. So let's hurry up and finish this because I'm getting tired. I know you are. So let's put the hot plate on here. So what I'm going to do is I'm going to go into assembly and I'm going to click insert components. What that's going to allow me to do is it's going to pop up this dialog box that we have at the very beginning. And it's going to say, hey, we have these two open documents. If I wanted to put it in another structure, I could. Connect them together if I really wanted to. I can make a monster pancake printer. It's just an amalgamation of multiple ones. I don't want to do that. Instead, I'm going to take the hot plate and I'm going to put it in. You'll notice I click once on it. It assumes I'm going to put it down. I'm just going to go ahead and put it somewhere over here. This piece I cannot move. If I click on it and drag, it gives me the error message. The selected component is fixed. It cannot be moved. Okay, this piece right here, well, it's basically like having a part laying around on the table. It can go wherever I want it to. I can move it and throw it up and down. I can bounce like a basketball. Sorry, I just get really happy. I have no idea where in space this is. If I rotate a different direction, I can move it more in the XZ plane. If I rotate it in this direction, I can move it more in the XY plane. But I really don't have any idea where this thing is in space. And SolidWorks doesn't either, because SolidWorks is waiting for me to tell it. Now this is already nicely oriented. This is going to fit nicely right in there. But how do I make that happen? Well, the first thing that you do is I emphasize in your drawings, make sure to add relations. In an assembly, you also add relations. But in assembly, they're called mates. You know, hi, good day, mate. Gonna put another mate in the barbie. Gonna put another mate on the hot plate. It's a mate. And what a mate does is it tells you, here are the relationships between components. So in a part, your relations tell you what are the relationships between points, lines, edges. In a mate, it tells you relationships between edges, points, parts, spaces, between two different parts. And the goal of putting in a mate is to try to make things stick really nicely together. It's not easy to do mates in SolidWorks. Most everybody messes this up. So if you do have any issues with mates, please send me an email. We can do a Zoom meeting. I can look at your drawing. I can help you out. If you're a SolidWorks expert and you don't need that, you do you. Okay. But right now I'm gonna create a mate. I'm gonna put this piece right here. What I want to do first is I want to make it so the first thing I want to have happen is I want to align my bolt holes. I created 4 bolt holes. I only need to align 2 of them. If you think about it, if I were to show off some of these really nicely made wooden coasters, if I take these 2 pieces and I were to drill a hole right on this corner, and I align this corner here like this, with this corner on this one, I can still rotate it about here. It's like imagine you put a bolt through these 2 corners. I can still rotate it this way. If I put a bolt through these 2 corners, I can't rotate them anymore. I have added sufficient constraints that now these 2 pieces are basically fixed together. Okay? If the bolts are long enough, though, I can still pull them apart this way. I cannot rotate them, but I can pull them apart this way. So we only need to align 2 bolt holes. I'll show you that right now in this drawing. I'm wondering how me having a live view of me is working. I'm going to watch this video afterwards and probably say some mean things about myself. So first things first, I want to align this hole and this hole. One of the things that SolidWorks automatically does is it hides the axes of all of your circles in an assembly. You actually have to go in and manually change that. So I'm going to go up to File. I'm in my Assemblies drawing. Go to File and Properties. Okay. It must be. Where are you? Not appearance. Oh man. Oh, sorry. You go up to View and Display. Now this gives you all of the different options of things you can display. Everything that looks selected has already been picked. You can show them as you want. Where is it? Seeing what I want to see. It's not on display. Well, I'm sad. I thought I knew how to do this. Tools. What was it? View. Okay, well. Oh, it is. Yes. Okay, so it's in View, Hide Show. If you go into Temporary Axes, what this will do is if I click on this, the box gets grayed out, meaning I'm showing this. You can also show where each component center mass is. Be careful turning on too many of these because it'll kind of make your drawing really ugly very quickly. You'll just have information everywhere. SolidWorks keeps all that information, but I just turned on temporary axes. Now, if I zoom in on this really close, you'll notice there's a line in the center of that circle. That is an axis that was generated by the extrusion of the center point of that circle. Okay, this basically defines the center line of that circle. So once again, go up to View, Hide Show, Temporary Axes. I believe it also shows with axes, but I'm always used to doing it with temporary axes. Temporary axes are generated by extrusions that are not explicitly stated. Anyways, this one also still has that same line. It's an axis. What I will do here is I will connect this axis to the axis inside of this hole. Now there is no axis inside of that hole. So apparently I was right by doing the temporary axis instead of axes. There's my axis. I can see these two lines, and I'm going to mate them together. Don't want to have that selected. Look at it here. Okay, gonna go over here in my assembly menu, click on mate, wait for this to pop up. Mate selections works exactly the same way as adding relations. If you become really good at adding relations, you're gonna get really good at adding mates. I'm going to zoom in here on this axis, on this temporary axis, click it, notice it says axis 1, it even says what part it's on, zoom out, zoom in on this hole here, and this is axis 2 on the hot plate. Thank you for telling me my memory is low, SolidWorks. Yes, I realize I'm losing my memory. Okay, stop. These are coincident. If I make them coincident, it means that those two axes lie in line with each other. It's almost as if it is one axis that's just cut between the two pieces. That's what coincident means. If I make them parallel, it forces it to be that these two holes will always be aligned with each other like this. That's not really going to bolt them together, but it makes them parallel. I can also make them perpendicular, which does the opposite. Make sure that these two holes are always intersecting each other. It doesn't define its position in space. Again, that's not really all that helpful. If you select the outside rim of the circles, you can make them concentric, which means that the circles have the same axis. It's the same thing. I always like doing axes because I'm old. That's how I do that. But I'm going to go ahead and hit OK now. I'll get out of the mate menu. Hold on. I can still move this piece. Well, I can. I added a relation where those two axes, if you'll notice, if I'm picking this up and moving it around, I am unable to make this thing move such that those two axes break. Those two axes lie firmly on top of each other, and if I drag this up and around, it's like having a really, really long pin that goes through both of those holes. I can move the object up and down on that pin. Really, I haven't affixed these two items together yet. I have added a mate, which is good, but I'm not done. Now I need to mate this hole here with that hole in there. So I'm going to go ahead and click back on mate. It automatically selects face 1 because that's the last thing I had picked. Delete that. Zoom in so that I can see the axis. Click on it, make sure that it says axis and that it's on the hot plate. Zoom out, zoom in. Wait for this to turn orange. Oh no, it just turns light blue. It never turns orange. Axis 2, this is on structure. I have axis and axis. I want them to be coincident. I'll hit yes. Okay, and then I'll click out of the mate. Now, when I have done that, if I am to zoom out here, I cannot rotate this piece at all anymore. It's like it's now on two pins that are infinitely long, and I can just slide this hot plate up and down on those pins. Not the prettiest, but it is still getting more and more defined. Okay? Now you'll notice I don't have to add mates in these bottom two. I will not, because that it begins to over-constrain the drawing. SolidWorks hates when you put too many constraints on something, which is valid. So having just those two bolts in, we're fully defined there, we're done. But I can still move it up and down. I want to make it so that this plate sticks to the structure. So what I'm going to do is I'm going to select the bottom face down here of this hot plate, and I'm going to bolt it, smashing it into this face right here of my structure. Okay, that's a different mate. So I'll go back into my assembly, click on mate, wait for this to pop up, zoom in, I'm going to select this face. Okay, you notice it pops up as face. The entire structure turns very dark gray because you're not going to mate something to itself. That's impossible. It would require the part to actually flex. You can't do that. So the entire rest of the part gets dark. Only the face in question becomes blue. And then you zoom in to the other part, which is right here. I want it to be the bottom of this face. If I pick the top of the face, it actually pushes it so that the two parts are inside of each other. That's not so much fun. But I click the bottom of that face, and then if I zoom in here, you'll notice my holes are aligned. I got nice cut holes. This piece is sitting on top of my structure, and I have effectively connected them together. You'll now notice this is two pieces. If I go in here, click on this, oh, lost my menu because I threw it down there. That's awesome. Don't do that, by the way. Maybe I can get it back. So look at how many web browsers I've opened at the same time. Thank you, SolidWorks. Come on. Well, I can't do that, so I guess there's no use. Thank you again, SolidWorks. What I can do is go ahead and click out of this. I can click on Edit Appearance. I'm going to, just for funsies, I'm going to edit the appearance of this material. I got hot plate selected, click Edit Appearance. And I'm going to want this to be black because it's a hot plate. Well, only it's changing the color of the face. I don't want it to be just a face. I want it to be the entire part. Instead of face, I'm going to go ahead and delete the face. I'm going to select part. I'm going to go in and I'm actually going to pick that part. Now the whole part turns black. Okay, you can change the transparency, you can change the hue. Instead of being a dark black, I think I kind of want it to be like just a darker gray. Okay, that's fun. Say good for that. Then I'll go in and do that again for the structure. What color do I want the structure to be? Well, I want this to be red. But yes, now you'll notice I have two different parts. Both look very pretty, sitting inside of each other. Can't get the right view, so I'm going to click on a corner view of this. Oh, that's fantastic. Nice. Beautiful. And there's my pancake printer so far. I am going to put in some components up here, an extruder nozzle, and that'll happen next week. For right now, I'm going to save this assembly file, and I'm going to save it as, once to make sure that I'm saving all the parts with it, because remember, it's referencing those parts. Save all those parts, and I'm going to save it as assembly, put it in my pancake printer folder, assembly. There we go. Okay. You will have a modeling learning assignment due Tuesday. You will also have a reading assignment due Tuesday. I will post both of those today, hopefully. If not today, then early tomorrow morning. I expect you to get those done by midnight on Tuesday. You will also have a quiz over this week's topics. We discussed generating form, so make sure to watch that lecture. I may ask you some questions from this lecture too. Everything is fair game. I assume you go to class. But that quiz will also be due on Tuesday night. So if you have any questions, feel free to email me at any time. I try to respond as quickly as possible. If you email me at 4 in the morning, I don't sleep. Also, I haven't had any caffeine today, and I'm basically about to take a nap. All right. Good luck. Have a good rest of your week, and I will see you next week.